Right now, water is moving through your home's filtration system, and it is not doing what you think it is. The cartridge you replaced 3 months ago is already degrading. The bottled water you bought last week came from a municipal source that had its own contamination profile, and somewhere downstream of all of it, your tap, your glass, your gut, something is getting through that the system was never designed to stop. That is not a theory. That is the documented failure mode of most consumer water filtration products sold in the last 40 years. And somewhere in a 1961 FEMA Civil Preparedness Manual, the answer to that failure was already written down. A $3 mineral, one handful, mixed into any soil column or layered into a simple gravity filter, documented by civil defense engineers, tested in the field, and used in municipal water treatment across Eastern Europe and Japan for over 5 decades. It was never a secret in the technical sense. It was something more useful than a secret. It was ignored. Here is what that cost you. The average household water filtration system runs between $200 and $800 up front. The replacement cartridges come every 3 to 6 months. Multiply that across a decade, and you are looking at well over $1,000 spent. And that is before you count the bottled water market, a $280 billion global industry, built almost entirely on the premise that your tap is untrustworthy and only a branded product can fix it. But here is what most of those systems quietly skip over in their marketing. Activated carbon filters, the standard in nearly every consumer product, are optimized to remove chlorine, chloramine, and the compounds that affect taste and odor. They address aesthetics. What they do not reliably remove are heavy metals like lead and arsenic, dissolved ammonia, agricultural runoff chemicals, or certain industrial contaminants. The filter makes the water smell better, but it does not make it chemically cleaner in the ways that matter most. The soil beneath your feet, as it turns out, has always known how to do both. This is where the story shifts. There is a mineral called zeolite, specifically the naturally occurring form called clinoptilolite, and it has a structure unlike almost anything else in the geological record. At the molecular level, it is built like a cage, a rigid crystalline lattice with channels and cavities sized to trap specific ions. The chemistry is called cation exchange, and what it means in practice is this. As contaminated water passes through zeolite, heavy metals, ammonia, and dissolved chemical compounds are physically pulled out of the water and locked inside the mineral structure, not filtered around, not masked, captured. The U.S. Civil Defense Program understood this by the early 1960s. Field tests documented zeolite's capacity for emergency water purification in situations where conventional infrastructure had failed. The material was cheap, stable, and available. It required no energy, no proprietary housing, no subscription. Then Chernobyl happened in 1986, and the Soviet government distributed zeolite at mass scale, not as an experiment, but as a response to radioactive cesium and strontium contaminating water supplies across affected regions. Studies later published in the Journal of Hazardous Materials confirmed the removal efficiency. The EPA assessed natural mineral filtration alternatives in internal technical reviews. Municipal water treatment plants in parts of Poland, Hungary, and Japan integrated zeolite filtration columns as primary or secondary treatment stages. The material was not obscure, it was documented, peer-reviewed, and operationally proven. Then consumer awareness of it simply never developed. That was not the discovery, that was the problem. Think about what a material like zeolite represents to an industry structured around replacement cycles. It cannot be patented in its natural form. It cannot be locked into a proprietary housing. It does not degrade on a branded schedule that triggers a recurring purchase. A household using zeolite in a simple layered gravity filter is a household that does not need a subscription. An industry cannot easily profit from a fix that ends the cycle, and so the fix does not enter ordinary consumer language. They did not need to suppress it with force, they only needed to keep it out of the conversation. The water filtration market is projected to reach $45 billion by 2030. That projection depends on consumers continuing to replace what they were never taught to understand. The agricultural sector never lost this knowledge. Zeolite has been used openly as a soil amendment for water retention and contaminant absorption for over 40 years. It is in farming literature, it is in veterinary practice, in aquaculture, in industrial wastewater processing. The information was never erased, it simply never crossed into the language of the household. That was the design. So here is what you do with this. Zeolite powder, clinoptilolite grade specifically, is available at garden supply stores, agricultural co-ops, and online retailers for $3 to $8 per pound. In a DIY gravity filter built with layered sand and gravel, you add 1 to 2 inches of powdered zeolite beneath the sand layer. In a container-based system, the documented effective ratio from municipal scale research is 50 to 100 grams of zeolite per liter of filter media. That is the number that appears in the technical literature, and it scales down cleanly to household use. One honest thing needs to be said here. Zeolite is not a biological filter. It will not neutralize pathogens, bacteria, viruses, or parasites. For that, you still need boiling, UV treatment, or a quality activated carbon layer working alongside it. What zeolite handles, heavy metals, ammonia, agricultural chemicals, dissolved industrial compounds, is the category of contamination that most consumer systems leave largely unaddressed. It is a chemical filtration layer, not a complete replacement for every other method. Use it as that. The mineral has been in the ground for millions of years. The documentation has been in the archives since 1961. The price has stayed under $10 a pound. None of that changed. What changed is that an entire consumer industry grew up between you and the information and found that confusion, replacement cycles, and branded dependence were far more profitable than clarity. You now know what civil defense engineers wrote down 6 decades ago. The real cost was never the water, it was never the contamination. The real cost was not knowing this, and this is only one buried answer among many.